Coming back to the structures, then in the next slide we have a simpler syntax for the structures. And what does it mean? Whenever we are writing a code and we are writing as per the norms or the conventional things that we are expected to do, then we can simplify the code in a certain way using a shorthand method. So what the shorthand method is, similarly we have declared a structure over here and we have made an variable for the structure, and how we can give the values. Earlier what we were doing was we were doing it in a way like we were writing s1 dot mynum is equal to 30, right? And separately we were giving the values, but that would utilize 3 lines of code. That is not going to increase the complexity in a certain way, but that is going to increase the length of the code, and it will eventually make it less convenient for the user to read or to understand. So in order to decrease that length of code and make it easier for the understanding purpose and to decrease the workload, there is a shorthand for initializing, or we can say giving a value to a structure variable. So how we can do is we will certainly define a structure variable, this struct my structure s1. We will write equal to open curly braces, and in order to what the variables are defined inside the structure, like first we have defined my num, then my letter, and then my string. In order of that only we are going to declare the values. Like for my num we will give this 13, then we'll give b, and then we'll give sum. And now if you have put this sum text value here inside my num, it would show an error because this is of integer type and you're giving it a character array type of value. So that we need to avoid. So this is basically a simpler syntax for how the structures can be initialized with the values. Moving on further, we can copy the structures as well. Like if this is a structure variable s1, this is the structure variable of s2. Here some values are given to my num or some variables, and here the values have to be given. So we can write s2 is equal to s1. So what will happen is, if we are going to print s1 dot mynum, it is going to print 13. And now as we have copied the structure, then s2 dot mynum is also going to be equal to 13 only. Means the structure has copied all the variable values that were defined for structure s1. So this is as simple as that, and this is the concept of copy structure. So if we have to learn it in a proper way, then we can say that first we define s1, and s1 dot mynum was equal to 30, and now then we wrote s2 is equal to s1. And now if we are trying to print s2 dot mynum, and what can you expect? What would be the value that is going to be printed? So that is going to be 13 only. Why? Because we have made it as an equal structure, or we have copied the structure, right? So basically this is a real life example of structure concept. And if we are learning, or we can learn structure well, then we need not worry about the union concept. So for that real life example, we have taken a structure named as car. So we might take the variables as the car attributes, like what the car attribute can be. So that can certainly be the brand of the car, that can be taken as character array, the model of the car, and the year in which it was manufactured. So there can be many as well, like color, price, right, the measurements of the car, but we are certainly taking only 3 variables here, or 3 entities or 3 attributes here. So the brand, model, and year. Year is the integer type, and rest all other are character array types. So now we are declaring 3 cars. So this is the car 1, struct car 1, struct car 2, struct car 3. So the first car has been assigned with a brand of BMW, with the model X5, with the year of manufacture 1999. So this is particularly one car. This is about one car. This is about BMW car. And for the car 2, the values are Ford, Mustang, and 1969. And for the car 3, we have Toyota, Corolla, 2011. So these are related in a way that this is car 1, this is car 2, and it has its specific attributes of brand, model and year. This car 2 has different values for the attribute, and this car 3 would definitely have different values that are defined here by the users. Right, and now if we are going to print car1 dot brand, then first it would go to car1. So here it is car1. Now it would go to brand. So for brand it would going to print BMW. So this is how the values can be printed for all the structure variables that are declared. So moving on further with the concept of union. So basically a union is similar to somewhat or the other structures. We can say that for the same memory location or the memory address, we are like if we are declaring a union, that would occupy a memory address in the memory, and in that same memory address we can define different or many data types or variables. Like if we were declaring integer type, that would take a memory value. Let us suppose it is taking 1000 place in memory. If we are declaring double, it is going to take 1200, let us suppose. But what if we want it in a certain memory location only? So if we are going to declare a union that is occupying 3000 memory value, then at that same address we can define integer also, double also. This is how the union concepts work, and this is just like similar as structure. We need not see anything more in union concept. So how we can declare a union? It is just like the same structure method. For structures we were using the keyword struct, but for union we are going to use the keyword union. So this is a union and union keyword, and this is basically a user defined name or an identifier. So you can define it, you can give the variables just like we were giving in structures. So this is how you can do it for union as well. And if we see a proper program, then here the union has been defined, and now the union variable has been created. So we were creating for structures, we were writing struct and structures name and then the variable name. Here we are just going to replace the keyword struct with union, and all the functionality is same. Like we are writing data.I equal to 10, so we are accessing this variable for the data structure variable, and similarly we are going to print the values or the variable attributes just like we were doing for structure. So this is quite similar concept. And if we come to the differences between structures and union, because they just look like the same, the declaration is the same, their properties are almost the same, then what basically is the difference between these two? So the first and the foremost difference, we can say that here we are using a keyword known as union, and there, like for union we are using a keyword union for declaration and creating its variables, and for structures we use the variable struct. Remember not to use structure as the keyword, but the keyword is struct. The other difference can be the implementation of structure in C occurs internally, because it contains separate memory locations allotted to every input member. Means under structure, if we are declaring integer A, integer B, so integer A might have 100 memory location and it might have 200 memory location. So this is going to be different. But under union, if we are declaring integer A and integer B, and if integer A has 100 memory location, then integer B will also going to be having 100 memory location, because this is under a union which have the memory location 100. So all these memory locations of the attributes are going to be same in union, and in structure it is going to be different. So this is how the difference works for union and structures, and rest all the calling and defining methods are quite the same for these two. So this is how we have seen the flow of control. This is the declaration, this is the creation of variable part, this is the initialization of the members of the union, and this is just the printing part, like data.ia. So it's going to print the same thing that we have declared above. So this is how the union concepts work.